In the previous video I showed that I had obtained a set of ROM dump files for the HP9830A desktop calculator that I'm trying to repair. So these dump files are the octal values found in the system ROMs, ALU ROMs and the microcode ROMs. If you recall from the previous videos, I had read the main system ROM from the ROM card and it didn't seem to match what was in the patent. So obtaining these files from an emulator that works, in theory, should allow me to compare them directly with what I downloaded from the machine and see if they were the same. Now, unfortunately, the emulator was written in Java 2 and I don't use Java, so didn't have it installed. So I spent quite a few hours installing Java and finding a suitable IDE so that I could install and run the emulator, and it works fine. So it's a really nice emulator. It really does look like the machine, and it seems to behave exactly as the machine should. So the next step was to take these ROMs and compare them with what I had in my machine. So the first step in doing that was to compile them all into a single file. They were of course in the separate ROM images to represent the ROMs themselves, except for the strange bit of decoding that the machine uses, and that resulted in a ninth ROM file that I don't actually need, so I'll be combining that into a single ROM. Once I'd done that, I ended up with this file. So this is a file that contains all the instructions in theory in the correct order as they should appear in the ROM set. Of course, these are octal with the leading zeros removed, and what I could then do is process this data and create two files. Now, of course, as ever, I created a software utility to allow me to compare those two files. So we have the one that's compiled from the data from my ROM set, and then there's the one that's compiled from the data from the emulator. And what these are simply octal versions of the files. So in theory these should be identical if the two ROM sets are identical, but of course searching through these manually would be a very tedious thing to do. So I just wrote a very simple application to compare them, and when I run this application, what we see is that for the most part the files are the same, but there are 387 differences. Also, if you watch this being processed, you'll see that the errors jump up in fits and starts. So it appears there are 4 blocks of code that are incorrect, so most likely 4 failed ROMs, or just 4 locations where the firmware has been updated. I've got no way of knowing at the moment which of those is the case. But one thing that did occur to me is that, well, if the files I've obtained from the emulator are valid, that is, they run in the emulator, then in theory I could do the reverse and take the files or the data I've obtained from my ROMs and copy that across to the emulator. If the emulator still runs, then I can have some confidence that the code that's in my ROMs should actually run the machine. If the code will not work in the emulator, then again I can have a reasonable degree of confidence that there is indeed at least one failed ROM in the ROM board, and in which case what I can do is, as you know, I'm making a replacement ROM board, and I can then just use the data from the emulator to program the ROM on that board, and in theory the machine should work, at least as far as the code is concerned, and it will just be a case of dealing with any remaining hardware issues. But that will be far easier than trying to step through the code, because the code in either of these files does not match the patent. Then it's very difficult to step through the code, because I have to essentially decode each instruction and see what it's supposed to do, and that's of course very time consuming. So what I need to do is take the hex file that's been created So this is the hex file that I created from the ROM set in my machine, and I need to turn that into a format that is consistent with the information that the emulator needs. So in other words, I need to reproduce this set of dump files from that file. And again, I thought the easiest way to do that would be to create an application. So that's what I've done. It takes as a source file the combined data in octal format. So if we look at that file, you'll see it's just the output of one of the utilities that I wrote. But this is now the combined data from all the ROMs that are in my machine. And what I can then do is just process that data. It's very quick. It's converted that data into a set of dump files. And if we then look at the dump files, we'll see that they are very similar to the dump files that came from the actual machine itself. So if we compare them side by side, you can see that for the most part, at least looking through them manually, they look the same. Now if you recall from the video in which I looked at the data on the analyzer, you remember that it was a second set of ROMs that initially were causing the problem. So if we open the second ROM set, so we now have both ROMs, you'll see that straight away there is an issue in that they're not the same, and it appears that it's a single bit error, so it's unlikely it's just a simple firmware change. It could be, but it's unlikely, and it does seem that one bit on the ROM in this location on the board is stuck, it's faulty. So the next step is to get this set of ROM dump files copied across to the emulator and see if the emulator still actually runs. If it does, then chances are this is just a firmware change, and if it doesn't, most likely it's a faulty ROM. Okay, well, I've tried copying this ROM set across to the emulator, and sure enough it does not run. I'll do a bit more testing on it, but it does look like this is a non-valid set of firmware. I'll go through and just do a reverse sanity check. I'll reprocess this data in the same way that I processed the data from the emulator in the first place, and make sure that the reverse process results in the data I started with, just to make sure that I haven't introduced a bug along the way somewhere. But it is looking very like it's just a faulty ROM or two within the ROM card. In which case, of course, next step is to get the replacement ROM card made up and get the firmware from the emulator programmed in and see if that brings the machine to life at all.